So in this question, we have been given a particle is fired from the surface of the earth vertically above with velocity v0, where v0 is not small. Therefore, we need to find out the maximum height attained by the particle. In these type of questions, the first thing that should come to your mind is mechanical energy conservation. Since the external forces acting on the object are zero except the only gravitational force acting, but that will be taken into account by the potential energy. So work done by external forces is zero and the work done by internal non-conservative forces is zero. Therefore, we can apply mechanical energy conservation. So by applying mechanical energy conservation, we get potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. The initial potential energy of the object can be given to be mass of the earth is given to be m and r minus gm, m upon m is the mass of the object upon r, that is the radius of the earth since it is initially at the surface. Initial kinetic energy given to the object is half m v0 square. This is equal to final potential energy, that is equal to let it rise to height h above the earth's surface, and its velocity becomes 0 over here because this is the maximum height. So the final kinetic energy is 0 and the final potential energy is minus gmm upon r plus h. This concept is used many times. It is also used to find out the escape velocity. In the case of escape velocity, you have to equate the final potential energy to 0 because escape velocity means that it escapes the surface of the earth, it escapes the atmosphere of the earth, it goes outside the earth, so virtually it goes to infinity, and at infinity the potential is 0. So for finding out the escape velocity, we equate the final potential energy to be 0 and we get the equation. You also remember this, escape velocity is equal to root over 2 gm upon r. So if we give velocity greater than this, the object escapes from the earth, and this is just a side business. Let us come to the actual thing now. This question just now requires the solving for this capital H. We first cancel the mass from here to get minus gm upon r plus v0 square by 2 is equal to minus gm upon r plus h. Now gm can be written as gr square. This is always true. Because g is equal to gm upon r square, we substitute it here to get minus gr plus v0 square by 2 is equal to minus gr square upon r plus h. That is r square upon r plus h is equal to r minus v0 square upon 2g. Now we get r plus h is equal to r square upon r minus v0 square upon 2g. From this equation we get h is equal to r square upon r minus v0 square upon 2g minus r. So this is our final answer for the height, maximum height attained by the particle when it is thrown with velocity v0.